Hello everyone. In the previous video, we saw univariate analysis. I hope you implemented the code and practiced it well. In this video, we'll see bivariate analysis. So let's start it with importing the libraries first. Importing the libraries. And then we'll import pandas library. Import pandas as ED. We'll import matplotlib. Import matplotlib.pyplot as plt, and we'll import Cborn as SNS, and we'll import math library also. Okay, so first let's run this. Perfect. Now let's import the dataset. Here we are using credit card approval dataset. Importing the dataset. We'll give it to the variable data equals to pd dot read csv, and the dataset name is dataset.csv. So just add it in the quotes here, dataset.csv. We'll print the head of the dataset, data frame I mean. Let's run this. So here we have different columns: gender, age, debt, married, bank customer, industry, ethnicity, years employed, and so on. Now let's get a summary of data using info method of the data frame, data.info. Run this. So here we see the data set contains 690 entries and 16 columns, that is 0 to 15. Also, for each of the columns, the non-null count is 690, which implies that no column contains null values. Columns holding categorical data are gender, married, bank customer, industry, ethnicity, prior default, employed, driving license, citizen, approved, and columns holding continuous data are age, debt, years employed, credit score, income. Let's call duplicated method of pandas data frame to see if there are any duplicate rows. Data dot duplicated dot sum. Run this. We get 0 here, which means no duplicates. So now let's see bivariate analysis. The term bivariate analysis refers to analysis of two variables. The purpose of this is to understand the relationship between any two variables. Bivariate analysis is slightly more analytical than univariate analysis. When the dataset contains two variables and researchers aim to undertake the comparisons between the two, then bivariate analysis is the right type of analysis technique. Bivariate analysis of continuous variables, we'll see it first. Bivariate analysis of continuous variables. The first step in performing bivariate analysis between continuous variables would be to calculate correlation between them. We use core function to construct the correlation matrix. The Pearson correlation coefficient is a way to quantify the linear relationship between two variables. So we will start here by calling the data frame data, and then we'll call all the way columns here: age, depth, years employed, credit score, and income. And we'll call the correlation function for run this. So in this data set, we don't see any strong correlation between any two continuous variables. In some data sets, continuous variables could be strongly correlated and the values of one might depend on others. We can also draw line plots and scatter plots to see a relation between the two continuous variables. So we'll plot them here. SNS dot scatter plot data equals to data, and let's plot it for years employed, years employed, and phi equals to income. Let's also set the limit for it. PLD dot, let's set the y limit to 0, 20,000. Let's run this. The points in the above scatter plot don't follow any specific pattern. This might be due to people applying for cards coming from different professions with varying pay scales. Now let's see bivariate analysis of categorical variables versus continuous variables. Bivariate analysis of categorical variables versus continuous variables. We'll try to see how values of continuous variables behave for different values of categorical variables. We'll use the approved column of the data as the categorical variable for our analysis. Comparing the column approved with other columns can provide us some useful information. First, we'll perform the group by operation on the continuous variables. Group by allows us to split our data into separate groups to perform computations for better analysis. So, data dot group by, and we'll group it by the column approved, and we'll get the mean of it, aggregate mean. We'll get the mean for all the columns. Let's just copy this. Here. Now run this. In the above table, we can see that average credit score of people who got approval is more than people who didn't get the approval. The same pattern is observed in the income and years employed columns also. So this is very understandable because companies don't issue credit cards to people with low credit score and low income. Also, companies prefer decent employment history for issuing credit cards. So now let's see KDE plots. A kernel density estimate KDE plot is a method for visualizing the distribution of observations in a dataset. Analogous to a histogram, KDE represents the data using a continuous probability density curve in one or more dimensions. We'll plot KDE plots of continuous variables with U parameter approved. Let's start it here. ELT dot figure. We'll set the fig size to be 6,6, and then we'll use KDE plot function of SNS library. KDE plot data is our data frame, and X is, let's plot it for age. Q is approved, And let's set the fill parameter to be true. Let's run this. Here is the plot. Similarly, we can plot KD plots for credit score and years employed also. First, let's plot them. SNS.KD plot, where data is data. X is, first let's plot it for credit score, and U is root. Set the fill parameter to be true. Run this. Here is the plot, and before analyzing it, let's also plot years employed. SNS.KD plot, data is data. You just have to change your X variable here to years employed, and U is root, and let's set fill to be true and run this. In the above plots, we can see how distribution of variable behaves separately for approved and rejected classes. So now let's see bivariate analysis of categorical variables versus categorical variables. Bivariate analysis of categorical variables versus categorical variables. Now we'll try to see the relationship between categorical variables. Again, we'll keep the approved column fixed and we'll compare it with the other columns. We'll plot count plots of categorical variables first. We'll use the count plot function of SNS library, sns dot count plot data equals to data. X is approved and U is, let's plot it for gender. Let's run this. By looking at the above plot, it does not seem that the gender of applicants is considered a criteria to approve the applications. We can also plot a contingency table to get the actual numbers. Let's plot it using pd dot cross tab data dot gender and data dot approved. Let's set the margins to be true. Run this. See, here you get the values. And to see the percentages also, first you need to assign it to a variable. All is pd dot, same one again, cross tab data dot gender data dot approved, where margins set true. You just need to add all here and pd dot cross tab data dot gender comma data dot approved dot will divide it all comma axis is 0 and will also drop null values if any. Drop null. We'll run this. See, in the above table, we can see that the acceptance percentage for both the genders is very close. 53% is close to 56.4. Hence, it seems that there wasn't any discrimination against any gender. Let's plot for ethnicity also. SNS dot town plot data equals to data. X is approved and U is ethnicity. Run this. So here we see that for Latino ethnicity, most of the applications were rejected. Let's explore it more and find out why. First, we'll apply group by operation on the data. Data equals to, data dot group by, we'll group it by approved and we'll get the mean of everything. Uh, we'll consider all the columns here: age, depth, years employed, credit score, and income. Let's run this. Now, we'll filter the rows with ethnicity equal to Latino and take mean of the required column variables. That is data. We'll consider the data where data dot ethnicity equals to Latino only, and we'll get the mean of all the columns here: age, depth, years employed, credit score, income, and we'll get the mean of them. Now, let's run this. Now, if we compare the mean credit score of Latino ethnicity with the mean credit score of overall approved applications, that is, the mean credit score of Latino ethnicity is 1.85 and the mean credit score of overall approved applications is 4.60. They find that the Latino had less credit score than the population with approved applications. The same can be seen in income column, where Latino has average income of 434.64, where the approved applications have average income about 2000. So this is the reason for the rejection of most of the applications of Latino ethnicity. Let's also plot for variable employed. SNS dot count plot data equals to data. X is approved and U is employed. Let's run this. So here is the plot. And now let's also plot for the variable bank customer. You simply have to change the name. You simply have to change the X variable there. Count plot data is data. X has to be uh, X has to be approved and U is bank customer. Run this. So here it is. So this is it for bivariate analysis. In the next video, we'll see multivariate analysis. Until then, keep practicing with more data sets, keep experimenting different things. Bye.